let's use Euler's method because they said so. They'll always say so. In real life, though, you would use this in situations like you've seen where you would not be able to separate the variables in your differential equation. If that didn't make sense, watch the last video again, or hang tight, you'll see it in a lesson coming up soon. Things are a little different in this case because they did not give you the actual equation for the slope, but let's just read. So for a function, it's known that f of negative 4 equals 12. Oh, fun, good to know. That actually is our initial condition. That's our starting point. Not all starting points are at 0, just saying. Selected values for the first derivative are given in the table below. So they did not give us, grabbing the other side of the notes, yours is on the other side, mine's on paper. They didn't give us this, they didn't give us this, they gave us a table of values. It's going to come in handy. What is the approximation for f of negative 7 obtained by using Euler's method with 3 step sizes of equal length starting at x equals negative 4? Okay, so let's just write a few things down. Normally I would write things down just to get a good starting point. My initial condition is negative 4, 12. And my dy dx is, you don't know it. And that's okay. See the table. Oh, well, see the table? Sorry, couldn't resist. And so delta x is, this one's a little tricky. So we're going from negative 4 to negative 7. So we're going to go from negative 4 to negative 7. How far are we going? We're going 3, but we're actually going backwards 3, and we're going to use 3 steps to get there. So every step, we're actually going to be moving backwards. So instead of all these pictures I've drawn in the past where I'm like, we're going to start and we're going to go and go and go, and I'm always moving to the right. Well, now we're moving to the left, everything you own in the box to the left. So let's do it. Same chart, x, y, dy dx, delta x plus y. Why not? Our initial condition is negative 4, 12. Okay. dy dx, don't have an equation. Delta x is negative 1, y. So if you want to, you could come over here and just write down everything you do know. You do know that delta x is negative 1, so it's going to be negative dy dx, and then plus y. We know that much. So we will proceed. We're going to get all the way to negative 7. So negative 5, negative 6, negative 7. We're counting backwards, and that's okay. So negative dy dx, and then plus y. So negative something plus 12, right? Well, what is this? Well, what is this when x equals 4? And I know you might be tempted to be like, I don't know where to plug it in. Just table. See table. So there it is. When x is 4, the slope is negative 1. So this is what I have, 13. Good to know. All right, let's keep moving. Negative slope plus 13. Well, my slope at negative 5 is 2. That gives me 11. This goes quick, doesn't it? Bad grammar. It goes quickly. We're going to plug in a negative 6 into the table. We get a negative 3, and then plus 11, and that's going to give me 14. Something feels wrong about this. Something feels very wrong about this. Something's wrong. Something's wrong. Hold on, hold on, hold on. No, I'm not wrong. I'm not. Okay. All right. Yeah, not wrong. 14. Done. That's it. But I didn't need that. No, you didn't, because you don't have to go all the way to negative 8. You stop there. So f of negative 7 is not necessarily, but is approximately 14 using Euler's method.